So like I was just alluding to, this one here, nowhere in these directions does this tell us this has to be a perfect square. Whereas down here, I'm telling you this is the one that has to be a perfect square. So some might be perfect squares, some may not. Just know that we don't have to make all these the same. So what we kind of started this whole chapter with, module section, write the equations that best match the area model. And then we've done it two different ways, factored, and then we've multiplied them out. So what we've done with this, we can, if I give you a certain amount of information, we should be able to fill in everything else. So if that's an x squared, the only way we're going to be able to get that is if these two lengths here would have been x's. And then if this is a negative 5x, the way we would have gotten the area of this one would have been this height, which is the x, multiplied by this length here. And since it's a negative 5x, that would tell us that that has to be a negative 5. What that then allows us to do is kind of make the jump. If we know this is a positive 35, then the only thing this could possibly be here is a negative 7. So that negative 7 multiplied by the negative 5 will give us this positive 35. All right. And then that would then tell us that for this area, it would have a base of x up here, and then the height would have been the negative 7, so this has to be a negative 7x. We've written this two different ways. If I wanted the multiplied out let's do the factored version first. So we could say that our area here is this length, the x minus a 5. So if I did x minus a 5, and then I have to multiply it by this width or this height right here, and that's the x minus a 7. That's what I'm referencing when I say the factored out version. So x minus 5 times x minus a 7. The multiplied out version would be a couple different things. We could actually do the multiplying out. So we could distribute here and say x and an x make x squared, and then the x times the 7 is a negative 7x. Then we took the negative 5 and multiplied, so we get a negative 5x plus 35. And we talked about how if we add like terms, you get minus 12x plus 35. That's our multiplied out version. But we don't necessarily have to do the multiplying out, right? That's really just us taking the x squared, adding these like terms to get this negative 12x, and then the 35 ends up being your last term. We could just look at each individual rectangle. The individual rectangles will give us the multiplied out version. All right. That's what we started with. They were not all perfect squares when we started. So again, keep that in mind so tomorrow we're not messing that up when we get to our quiz. This one now I am telling you, I'm specifically saying this needs to be a perfect square. So then that way allows me to give you a little less information. If this is a perfect square, then what has to happen? If this is an x, then this would be x, giving us our x squared. And then if this is a negative 10 up here, this would have had to been decreased by the exact same thing, which is a negative 10. So then we have the exact same thing as a length and the exact same thing we would have with our height. Then the negative 10 and the x would make a negative 10x here. This negative 10 multiplied by that x is a negative 10x here. And then the negative 10 times the negative 10 is 100. So the factored version is just the x minus 10 multiplied by the x minus a 10. And then the multiplied out version, if you wanted to actually multiply it out, feel free, but we really could just put the x squared first. And then we know these are always going to be our like terms. So we're going to add those together to get a negative 20x. And then the constant that we ended up with was a positive 100. All right. So there's a few of those. Just know if it's a perfect square, know if it's not a perfect square tomorrow. All right, when we do this little quiz. All right. Real quick, match those up real quick. See what you remember of this. If this was our parent function, y equals x squared, how did we know if we're moving down, right, left, or up? And then just do a quick little matching here. and then let's see what we got. So here's your square term in number 3. And outside of the square term, we subtracted 4. So if we put at the very end a minus 4, what that should have done, I can't really call on anybody because everybody's frozen right now, so I don't know who, if you have a hand up, sorry. A negative 4 right here, that means we're going to go down 4. So 3 actually matches up with the one directly across from it, which is A. All right. If we go to this one, we're inside of the parentheses. So if I look inside of this parentheses here, we've added a 4. If we kind of understand that's the one that actually kind of behaves the opposite way of maybe what we would initially think if it's a plus 4, that should be moving us left 4. So number 4 should be letter C. If we tack on a 4 at the end, which is what this one is doing, that's going to move us up 4. So number 5 should have been D. That's the one that tells us we're going to go up 4. And then if I subtract 4 inside, that's going to move us right 4. So then 6 should have been B. All right, so keep that in mind. I'm going to ask a question on that tomorrow too. All right, similar, so be able to do that. 7, do that one well, if you have the sheet. We'll do it. Let's just do it. I want to make sure we get through those last set of problems on this. So what I want you to do is just graph this. So the first thing you're going to want to do whenever you're graphing a parabola is know what the vertex is. In this case, I just tell you what the vertex is, so we would want to plot that. So 1, -9 would be right there. The axis of symmetry has to be a vertical line through that point. So that's why when we look at x equals a -1, it is a vertical line going right through this point. You were then told you have x-intercepts of -2, 0, so our graph has to go through this point here, and then it has to go through this point here. Notice how that also plays out. Oops. Where this one is 1, 2, 3 units away from your axis of symmetry. The other one is 1, 2, 3 units away. It's the whole idea of the axis of symmetry. It's the middle of the parabola. And then I just want you to put an x or a y-intercept of 0, -8. So that point we know. And then there would be one extra point we could put. If we understand that this is 1 unit away, then if I just go to the other side 1 unit away, that should have been another point that I would know was on my parabola because of the axis of symmetry. All right, and then from there, we can then sketch our graph. All right. All right, what's next here? Yeah, do number 8 real quick. I'm going to leave this. I see like the 2 people who are moving are still looking. Jump to number 8. If you need to get this down, get it down. And do number 8. Although some of you might not have this. That's our parabola. And there's number 8. Just tell me the vertex, tell me the axis of symmetry by looking at that equation. All right, let me see if anybody wanted to volunteer, but none of you move on my screen right now, so I'll just give this to you.
I'm not seeing any hands up.
Okay, the vertex, we hopefully know this. This would tell us that our x-coordinate is a -4. And then since we have that -10 hanging out at the end, that's the y-coordinate of our vertex. And then the axis of symmetry is always a vertical line, which is x equals all the time. And in this case, since our x-coordinate is this -4 here, the axis of symmetry must be x equals a -4. All right. That we should be pretty good at. That tomorrow, get those right. Number 9, we'll come back to that one if we have time. Again, I want to get to all of these. This was the new stuff here in the last few days, so I want to make sure we have this. Try number 10. So it says, which number, this is what you would have done, we've been doing for the last couple of days now. Which number can be used to fill in the blank in order to make this a perfect square trinomial? If you need to draw out the little square right now, feel free. But we also, towards the end of the class yesterday, we want to start talking about how we can do that without having to draw that out. All right, so see what you think for that, and then see if we can fill that in. All right, can anybody give me that one here? We'll see if anything pops up on my screen. I don't know why you're the only one I can see moving this group. What's interesting?
Yeah, that's great. Cam's got his hand up.
All right, go Cam. See if you start talking, if it'll make you move on my screen. What do you got, Cam?
Can you hear me?
I can hear you. Yep.
Okay. I chose 15.
That's what goes here?
Go plus? Okay, no, 225, I think.
Good. And how'd you get that, Cam?
I chose 15 from the 30x, and then when you multiply 15 times 15, you get 225.
Good. Because if we do the we'll do this one here just to kind of understand what he just walked us through. He basically took that 30, and the way he got 15 is he cut that in half, knowing that half of them would have gone into this rectangle or that square and that square from when we had done all those. And what that would have meant was we would have an x here and an x here, but that means we have a 15 right here and a 15 right here. So that 15 gets multiplied by itself, giving us a 225 in that lower right-hand corner. So that's what we're going to be tacking on here to make this a perfect square. All right, good. All right, so 11, same exact thing. Set that one up, see what we think. Or not, you shouldn't even necessarily need to set it up. So when we can hopefully look at and then just give that answer. All right, 11. I'm going to go Jenna. See if you're going to move on my screen, Jenna. What do you think, Jenna?
You divide it by 2 and then.
Did you finish that? All I heard you say was you divided by 2.
Oh, you get 16.
Okay, so you divide that by 2 to get the 4, and then that's what would get multiplied by itself in our model. So that's where she says the 16 would come from. All right, good. All right, 12. Try that last one without fractions or anything weird going on there. See what we get for 12. All right, I'm going to go Jennifer. What do you think, Jennifer?
49.
Good. Should get 49 here. We know we split those up into 2 separate rectangles or boxes. Each of them would have been a 7. Those have to get multiplied by themselves. That would give us our 49. All right, good. All right, 13. See what we think with this one now. This is one of the ones with the decimal. Actually, I might need my calculator for this one. So give me a minute. All right, anybody got that one? There's a nice calculator handy that can do this. This would be ugly. Let's see here. I'm gonna pick Vicky because I can't see anybody else. Oh, was he? Okay.
Yeah, I want to try it.
All right, go ahead, Ahmed. What do you got?
Well, what I got is 23 divided.
Okay, 23 divided by 2, and then what? Say that again. You broke up.
1.5 times 1.5, and then that should equal 132.25.
Good, perfect. Good. Cut that in half. You would have had 11 and a half and 11 and a half in the two boxes. Those get multiplied by each other. Should get us 132.25. All right, good. Thanks, Ahmed. All right, now these we're going to flip it. Now I'm going to give you what that, if we think this whole little area model is, this was x squared, this is 36. What are we going to get right here? All right, so now go backwards and tell me what you think that middle term is and see what you think. So I'll give you a second here to think that one through.
Looks like Cam's got his hand up whenever you're ready.
All right, what do you got, Cam?
12x.
Good. And where'd you get that from?
So I think I'm gonna explain it kind of weird, but it makes sense. So the only thing squared that equals 36 is 6.
Okay.
And then 6 times 2 is 12.
Good. So good. These have to be both 6s, right?
Yep.
So he knows he had to have 2 of them. So what he walked us through is he know he had to square something to get 36, and that was 6. So that's how he knew that both of these needed to be 6s. And since there's 2 of them, he multiplied by 2, and then that's, I have too many x's in there. That's where his 12 is then going to come from. All right. Yeah, that's perfect. All right, good. All right, 15, same thing. See what you think. That's all right, John. I'm not doing so well today myself with my internet connection at home, so just do your best. I'm recording it. If you want to look it over later, it'll be on Canvas, okay? All right, Mr. Kuba, let's pick on someone for me. See if there's any volunteers. If not, pick on somebody.
Doesn't look like there's any on.
You want to pick on somebody? I feel like I'm answering too many. Or should I just go?
You can just go this time. We'll pick on somebody else next time.
All right. 16x.
Good.
So minus 16.
Good. Should be minus 16x. To get that 64, we would have had to do 8 times 8. Those would have been the 2 values in the upper and left-hand corners. So 2 of those would then add up to be the negative 16. All right. The next thing that we've done here in the last few days that we want to make sure we're pretty good at, you're going to see a few of these tomorrow. Let me make a little bit of space to work. Is if I now ask you what is the vertex of this, or what's the vertex of this one, and this one, these last handful, when I'm asking you for a vertex. The way I'm giving you this right now, this is standard form. So if we go back to the one, we skipped over the graphing question, but that question, my guess, if I do scroll back real quick, if I ask you what the vertex of this one is, we'd all be fine. We'd say that's a 2 and a negative 9, because that's in vertex form. If it's not in that form, in order to graph or to find our vertex, then it's a little bit harder. And that's what we're dealing with right now, this being in standard form. Okay, so what we want to do is write this, and then it says as a perfect square in vertex form. All right, so, and then we're going to do that for these last handful. So if I'm going to do that, it's for the most part what we just kind of talked about here is, I'll do the area model again to get the first type of this one started also. This would have to be x and x to get our x squared. And if it is now a perfect square, that means everything has to be the same everywhere. So if this is a 121, which it is, because I'm telling you it is right here, the only way to multiply to get a 21 with it being the same number everywhere is with an 11 and an 11. And then this obviously then is 11x, this is an 11x. So the way that we can now write this, so let's write this right now, as an x plus an 11 times an x plus an 11. But what I've been telling you, if I want you to write it as a perfect square, what that's just meaning is don't write it as a product of the two the same things. Just write it as the quantity square. This one works out perfect. We don't have to add or subtract. Sometimes, remember how we're like adding some number at the end here? We don't need to do that with this one because it worked out perfect. That we actually get an 11x, an 11x, those together added up to be 22. And then when I do the 11 times the 11, it's the 121. So this is all set. We don't have to play any games where we're trying to figure out what number needs to be added or subtracted. This is our guy. So all that's really added on at the end here is a 0. We don't have anything that we need to add on additionally. So in that case, then we can just look at this and say that our vertex is a negative 11, 0. All right. The next one also should work out nicely. If we think about this as our little area model, if this is x and this is x, so we get our x squared, that this is telling us we have to get. Well, let's do it this way. If we have, this is our middle term, and it's a perfect square, that means I'd have to have the same amount here as I do here. So that's why we've been dividing by 2 a lot today when we've been doing these. Telling us that this has to be a 13 and a 13. And when we multiply 13 and 13 together, we get 169, which is perfect. That's exactly what we would need. So this is, again, another nice one of these where we don't have to add or subtract anything. So I can now write this as f of x equals x plus 13 times x plus 13. There's nothing necessarily wrong with that. But in order for it to be in vertex form, we want to write it as a perfect square. So we just write that as x plus 13 quantity squared. That's now in vertex form. Again, we don't have anything in the back. That just means it's a 0 for your y coordinate. So our vertex is a negative 13, comma 0. When we did these, people understood these pretty well. And then I slipped one like this, and then that caused us a little bit of discomfort, a little bit of doubt. See if we can now do this one. This is the one that's not going to work out nicely, where we have to now start adding a little bit or subtracting a little bit to make sure that we actually get this positive 10 as the number in the back. All right, and see if we can do that. Take a minute and see if you remember. This should have been your homework last night, so you should have done a few of these if you've done that and submitted it. If you think you wrote it right, then write down what you think your vertex is, and then we'll see if you got through it all the way. All right, let's see where we're at. Just make sure we get through these. So this x squared term, that's going to be this. And the only way we get that, if they're the same, is with an x multiplied by an x. If we go to the 16x, if it is a perfect square, that means both of these have to be the same. So that's why with a lot of these we've been dividing by 2. That tells us that this had to be an 8, and then that had to be an 8. We would like this to be a 64, right? I mean, if it was a nice one like 17 and 16 before it, then this answer right here, this number right here would have been a 64, but it's obviously not. All right, so if I currently have 64, but I only want to end up with 10, so as I go to write this now, if I go ahead and write f of x equals the x plus 8 times x plus 8 squared, when I do this, it's going to produce a constant of 64. I don't want 64, I need a 10. So what we said we can do, just a little shortcut to do this, all we now need to do is figure out how can I get the 64 down to a 10, and all we needed to do, we said yesterday, the wrong thing there, is take whatever this constant value was originally, just subtract away the 64 that we got. and that would be minus 54. All right, so this gives us 64. If we then subtract 54, that should give us the 10 that we're looking for. So if you went all the way through that and said that your vertex was a -8, -54, then you did that correctly, all right, which is good, especially as we're learning this right now. All right, any questions on that? Does that make sense? All right, then number 19, same exact thing. Try that one real quick while I make a little space. All right, let's see what we got here. We're getting a little close to the period, so I want to make sure we finish these two. If we just go in order, this x squared we have, and that's a product of an x and an x. We know the 6x, if it's a perfect square, means half of them would have to go here, half of them would have to go here, telling us that we increased the top by 3 and we increased the bottom by 3. If we wanted this to be a perfect square completely, our diagram anyway, we would get a 9 right here. What we want it to be is a 22. All right, so if we now write out what we have, you're going to have x plus 3 times x plus 3, so x plus 3 squared. And then we're trying to figure out, what do I have to do to this 9 in order to get it to be a 22? This one, we would just tack on an extra 11. But the little shortcut that always works is just going to the constant that we currently have in the original one, and whatever you're given, just finding the difference between that and what we need. If I did 22 minus a 9, that would give us our 11 right away. All right. Okay, one more. Make sure we get through this. So we're going to have last one. Here's our x squared. That's an x and an x. So that takes care of this guy. If I have a minus 8x, that means we have a minus 4x here. We put the other half of them right here. We know we decrease by 4. So if I go ahead and...
I don't think to answer that question.
Oh, yeah, go ahead, Cam.
On 19, wouldn't it be plus 13? Or am I tripping?
Let me see, maybe?
3 squared would be 9, and we got to get to 22.
Oh, yeah, good call, Cam. Yeah. What happens when I rush? Yeah, 22 minus 9 is definitely a 13. Good call. Yeah, so change that around. And then our vertex, I should probably be writing this down to -3 and then a positive 13. All right. All right, so now number 20. This should be currently x minus 4 squared. But if I do this, that's going to produce a constant of 16 down here. We don't want it to be 16. We want it to be a 1. All right. So if I want to go from 16 down to 1, because this would produce 16, down to 1, we would need to decrease by 15. Or just take the constant that's in the original version and then just find the difference between that and the number that we just added here. And 1 minus 16 would also give you that -15 pretty quickly. The vertex then we can now say is a positive 4 and -15. All right. All right, be able to do that tomorrow. That's really those last couple of problems, completing the square, being able to, figure out what we're adding or subtracting at the end is really the newest stuff that we've done this past 3 or 4 sections. So make sure we have a pretty good handle on that. The last thing I just gave you, what, don't worry about. We're going to run out of time. We're less than a minute. So just a real quick reminder, if you have the homework and you haven't submitted it yet, make sure we get that. We do have a quiz tomorrow. So if any of this is not making sense, you need some clarification or whatever, see Mr. Kubowitz or I tomorrow during the intervention period starting at 9:30. Just pop on. We can try to get you squared away if any of this is not making any sense. All right. But if you're good to go, then we will see you tomorrow. If you have a question now, you can hang out. But have a good Wednesday. Okay. We'll see you guys tomorrow.
Have a good day.
Thank you. You too.